Homework set 43, this is applications of linear systems. Question 1 says that one number is 3 more than 2 times another. So apparently we've got two numbers. One is 3 more than 2 times another. And then you know this, that the sum of the numbers is 12. Find the two numbers. Okay, so here's what I'm going to do. I know that one number is 3 more than 2 times another. I'm going to let x be the other number. All right, so start by introducing a variable. Let x equal the other number. Then I know this. What about the one number? The one number is 3 more than 2 times the other. So what is that? Here's the other number. It's 3 more than 2 times this. Now 2 times this I'm going to write as 2 times that, but it's 3 more. All right, that's equal to the one number. All right, so I've got both numbers. Now I know this. The sum of the numbers is 12. So the sum of the numbers is 12. So if I take x plus 2x plus 3, I'll get 12. We can solve this. How about 3x plus 3 is equal to 12? That's going to give me 3x is equal to, subtract that 3, 9. So x is equal to 3. Now, it's a word problem, so you've got to look back to what x is. X is what? The other number. Now, the instructions say, find the two numbers. I've got one of them. What's the other? Well, that's why I like to write this up here, because everything's in front of me. What is x? X is the other number, and then I have to get this one. That one is 2x plus 3, right? So that is going to be 2 times 3 plus 3. All right, that turns out to be 9. All right, so I have two numbers, 3 and 9. Now that's one way to do a problem. They're not always going to work where I can just have one variable. So here's another way to do this. I have two numbers up here. I'm going to do this. Let x equal one number, y equal the other number. Now here's what I know. One number is, how about this? One number, y, is 3 more than 2 times another number. Now, the other number here is x. 2 times x is written 2x and 3 more. All right, that's one equation. Now, I've got two variables. I've got two variables here, so I need two equations. I've got one equation here. Now, there's more information back here. The sum of the numbers is 12. So I could write x plus y equals 12. Now, there's a system of equations. And if I use substitution, right, here's what I know. Y is equal to 2x plus 3. So if I put that down here, it's going to look like this. I'll get x plus, and then the 2x plus 3 equals 12. And then what do you notice? That is exactly what we had up here. So then I can just solve this system, right? And I'm going to get one number is 3, the other number is 9. Question 2 tells that the difference of two numbers is 7. So if I take one number, subtract another, I'll get 7. Now this one says 2 times the smaller is 5 more than the larger. Find the two numbers. So it looks like they're telling us we have a smaller number and a larger number. So I'm going to do this. I'm going to let x equal the smaller. It doesn't really matter which you use, x or y, the smaller, and y equal the larger. Now I know this. 2 times the smaller, so 2 times the smaller is, I'm going to write that down. So 2 times the smaller is, so just write what you see. 2 times the smaller, 2x, is equals 5 more than the larger. So this is 5 more than the larger. Now the larger is y, but it's 5 more than that, right? So it says 2 times the smaller is 5 more than the larger. And I also know this. I also know, now see, I've got two variables, so I need two equations. I know this. The difference of two numbers is 7. So if I take the difference of 2 is positive 7. So I'm going to take the larger minus the smaller, and I'll get 7. There's our system. Now I'm going to solve this by substitution. This equation here, I can solve for y, right? Just add x to both sides. So here's what I get. I get y is equal to x plus 7. So I'm going to take that x plus 7 and put it in for y right here. We will get 2x equals y, but y is x plus 7, and then the plus 5. Now, let's subtract x. So I'll get 2x minus x is x equals 12. All right, so I got x equals 12. Now, what is x? X is the smaller number. Okay, so I got the smaller number. Now, get the larger number. So what do you know about the larger number? Well, we're told now that the larger, all right, 2 times the smaller is 5 more than the larger. So I've got it right here. So if I take 2 times that smaller, all right, 2 times 12, that's equal to the larger, but 5 more. All right, so this will give us 24 is equal to y plus 5. Subtract 5, this will give us y is equal to 19. All right, so find the two numbers. All right, so the smaller is 12, the larger is 19. Or if we just write 12 and 19, we know which one's the smaller and which one's the larger. Question 3 tells us right away the sum of 3 numbers is 16. So I'm going to have 3 numbers. How about 1 is x, 1 is y, and 1 is z? Now, I'm giving some information. Now, first of all, if I've got 3 letters, 3 variables, I better get 3 equations. So let's see if we can get one from here. Well, as I read this, I see 2 times the smaller is 3 less than the largest. Okay, how about if I do this? I'm going to let x equal the smallest number. And I'll let y equal the largest. Now, there's still another number, but I don't know anything about that one yet. It's just, here's what I know. 2 times the smaller, all right, let's write it. 2 times the smaller is 3 less than the largest. All right, now the largest is y, but it's 3 less than that. Now that's one equation. I see another one coming up right from here. It says the sum of the largest and smallest is 12. Now the largest, I let be y. The smallest is x. So I'm going to say that the sum of the largest and the smallest, that's going to be y plus x, that's 12. Now I need another equation. I've got 3 variables, but right now I have only 2 equations. Now that third equation is going to come right from the beginning. It says the sum of 3 numbers is 16. So I know that x plus y plus the other number z, that's equal to 16. There's our system. Now we could solve this by a pencil, or realistically, why don't we let Wolfram Alpha do this for us? So go here. Go to www.wolframalpha.com. You get this. Here at Wolfram Alpha, I want you to enter what you want to calculate. So we're going to type in solve. So just type in solve. Now type your 3 equations just as they are. 2x equals y minus 3, comma, separate equations with commas. Y plus x equals 12, comma, and then x plus y plus z equals 16. And then press either enter or that equal sign. And when you do so, this is what comes up. Here's at the very top, that's what you typed in. Then here's Wolfram Alpha's interpretation of what it thinks you typed in. So just be sure that what Wolfram Alpha says is what you actually wrote. And then down at the bottom is what Wolfram Alpha claims to be the solution. So what we're saying here is this, that x is 3, y is 9, and z is 4. Now here's the question up at the top. What's the question? Find the 3 numbers, right? Find the 3 numbers. Well, I've got three numbers here. The three numbers are 3. Oh, let me write it this way. The three numbers are 3, 4, and 9. The order doesn't matter. I could write 4, 3, and 9. But it wants three numbers. Here they are. Question 4 tells us that there are 775 tickets that were sold for a game for a total of this much money. Now, an adult ticket sold for $2 and children's tickets sold for $1. How many of each kind of ticket were sold? All right, so I want to know how many of each kind. So why don't I introduce a variable here? Why don't I let x equal the number of, say, adult tickets, and y equal the number of child tickets. Now we need to get two equations because I got two variables. Well, here's what I know. I know that adult tickets are $2 each. Now, how many are we selling? We're selling X of these. Just for example, what if we sold 5? How much would that be? If we sold 5 of these, it'd be what? $2 times 5. If I sold 10, it'd be $2 times 10. If I sold 20, it'd be $2 times 20. If I sold X, it will be $2 times X. That's how much money is brought in by adult tickets. And then what about children's tickets? Well, they're $1 each. And how many do we sell? We sold Y. So again, what if we sold 5 children tickets? Then I'd have $1 5 times. If I sold 10, I'd have $1 10 times. But I've got Y, so I've got $1 Y times. Now what is this? This is the amount of money brought in by adult tickets. This is the amount of money brought in by children's tickets. If I add them together, I get the total amount of money that's brought in. And that is this much right here. Right? $1,075. Now, that's one equation. I need another equation, and that's right here at the beginning. How many tickets did we sell? 775 altogether. X is the number of adult tickets we sold. Y is the number of children's tickets. So if I add those together, I'm going to get 775. There is our system. Let's make it look a little bit easier. How about this? 2x plus y equals 1075, and x plus y is equal to 775. Now, we could use Wolfram Alpha to solve this, but this is pretty straightforward. You see this equation right here? What if I solve for y? I get y equals 775 minus x. Now take that 775 minus x, put it right here. I'll do it up here at the top. It gives us x plus y, 775 minus x. So this gives us 2x plus y, but y is 775 minus x. That's equal to 1075. Now, 2x minus x is x. Subtract 775. I got 300. All right, now I got x equals 300, but what is x? It's a word problem, so you got to look back to the beginning to see what you let x be. X is the number of adult tickets. Now, what's the number of child tickets? Well, that's right down here. Here's what we know. That y is equal to 775 minus x, right? So I'm just going to take this and substitute it again right here, put it here, or if you wanted, you could put it over here, a little bit more work. But now what I'll get is this. Y is equal to 775 minus 300, so y is equal to 475. So, how many of each kind of tickets were sold? So, adult tickets, we sold 300. Child tickets, we sold 475. That brings to an end this part of homework set 43.